Hey, what's up, Math 1? We're going to take a look at 11.1, solving linear systems by graphing. This is Mr. Bainey. Thank you so much for watching. Our essential question here is, how can you find the solution of a system of linear equations by graphing? And graphing is the primary method we're going to be using here. And so we're going to go back to all the different ways that we know how to graph. There's some that are better than others or more efficient than others. And so if you're not comfortable with graphing, this is going to be some good practice, but you may struggle a little bit here. Um, and since we're using the method of graphing, the rest of this module is going to give us some other methods to doing the same exact problem. So let's first look into what is a system. What's a linear system? So when I say a system of things, we're talking about one or more. I'm sorry, we're talking about two or more of those equations. And the solution to the system means we're looking for a point that is on all of the lines that we're looking at, okay? So if you take a look at this graph A right here, then you can see the two lines. We mainly want to see this line right here has a bunch of points. This line has a bunch of points. Which point is on both lines? And one other way to describe it is it's the intersection point. So this point right here is a point that is on the first line and on the second line. In fact, it's the only point that's going to be on both lines. Okay, so as we go through this lesson, we are looking for that one point that is on both lines. Okay, on this next page, this is not going to be hugely important for the purpose of this course, but we have, for every system of linear equations, we can classify them as either consistent or as inconsistent. That's going to be determined by what type of and how many solutions it has, because although the first page, it showed a system that only had one solution, we could have different types of cases. A consistent system is when we have at least one solution, and that could be broken down into a consistent independent system or a consistent dependent system. So that can even be broken down into two more categories. Okay, but we're not gonna look at that very closely. We're just going to start graphing some lines and finding the solution. So let's do the your turn number 3. So we have the equation y equals negative 2x minus 2. I'm just going to graph it using slope-intercept form. And that means that my b is right here. It's the negative 2. And so I start at negative 2. My slope is negative 2 as well, which means I'm going to go down 2 and over 1. And the nice thing about using this method is that I can use the slope over and over and over again, and I stay on the line. So I'm going to go down 2 over 1, then down 2 over 1. I can also go backwards. So I can go up 2 left 1, up 2 left 1, up 2 left 1. So I'm not going to be using a ruler here. And the purpose of doing all these points is so that I get a nice accurate line. And we want accuracy because if we're trying to find out where they intersect and we got some crooked lines, we're not going to get a nice answer. So the second equation is a little bit tougher to deal with. It's x plus 2y equals 2. So here's one method. I'm going to show you another method in one of the other problems. I'm going to solve this for y. So let's subtract x on both sides. I get 2y equals negative x plus 2. Whoops. Negative x plus 2. And then I want to divide by 2 everywhere. So that means I'm going to get y equals negative 1/2 x plus 1. So that means I'm going to start at 1. That's my y-intercept, so b equals 1. And then my slope is negative 1/2. That means I go down 1 and then right 2. So down 1, right 2. Down 1, right 2. I could also go up 1, left 2. And up 1, left 2. And what's nice about getting all these points is you're usually going to find a point that is also already on the other line, like this case here. So there is my second line. Let's get a different color here, and I have my solution is right there at the intersection point. The solution is -2 comma +2. Okay, and that's all there is to it. So number 4, go ahead and pause it. Give number 4 a try. The solution is going to pop up in a few seconds. Here's a solution for number 4. As you can see in blue, I graphed the first equation using slope-intercept form. And so there's my line, the blue one. The second equation, I had to add x to both sides to put it into slope-intercept form. I got my intercept is 6, my y-intercept, and then my slope is 1, which is 1 over 1. And there's the second equation graphed, the red line. They intersect at this point, -2 comma 4. So that ends up being my solution. Okay, the next type of problem that you might come across is when you are solving a system by graphing and it doesn't turn out so nicely. So let's take a look at these your turns, 5 and 6. Number 5, the first equation, y equals -x minus 2. I see that the y-intercept is -2, so let's graph that right here. And the slope is -1 or -1 over 1. I could do -2 over 2 because it's the same thing. Because my graph, you can see here, the x-axis goes by 2's, the y-axis goes by 2's as well. So if I go down 2 and right 2, I get my line, and I can go up 2 and left 2 as well. Okay, so that's the first line. The second equation, I'm going to subtract the x on both sides, and I'm also going to subtract the 2 on both sides. And so I end up with y equals -x minus 2. So I see that I get -2 as my y-intercept. So that's right here. And -1 is my slope. So I'll notice that it's actually the exact same slope and the same y-intercept. And so if I were to get these same exact points, notice that my blue line and my red line are exactly the same. So you look at how many solutions, how many points are on both lines. This is going to be an infinite amount of solutions. Okay, because that line goes on forever. So infinite solutions. Number 6, let's graph the first one. First equation here in red, the y-intercept is -1. Now our x and y-axis goes by 1s here, makes that a little bit easier. Our slope is 2/3. And by the way, if you want to go ahead and try the rest of this on your own, go ahead and pause it whenever you feel the need to. So I can go up 2 over 3. I can also go down 2 and left 3. There's my line. Okay, and on the second equation, I'm going to add 2/3 x to both sides. And I get y equals 2/3 x plus 1. Looks like that's a positive 1. So I go positive 1. And 2/3 means I go up 2 and over 3. Up 2 and over 3. Or I can go down 2 and left 3. So I end up with this line. Sorry for making it crooked. But you can see that if I continued this slope and kept going, that it looks like this is never going to intersect. So if the main question is what point is on both lines, well, there aren't any. So we would say, in this case, no solutions. Okay, so these are the different types of special cases you're going to get. So usually you're going to see 2 lines intersect somewhere. In both of these cases, the times where you won't get one solution, this is what could happen. Okay, and let's practice a couple more here. These equations are going to be a little bit tougher to graph. If you want to just go ahead and pause it and try it for yourself, this is where we're going to have to estimate though. Okay, I'm going to do number 7 and explain it as I go through. and then you can pause it after to try number 8. I'm going to go ahead and the solution is going to pop up immediately after I'm done with number 7. So first equation for number 7, I'm just going to divide both sides by 2 to get y by itself. I want to put it into slope-intercept form. So I get y by itself equals negative 5/2 x plus 5. Remember, I have to do the 10 divided by 2 at the end there. So I got a y-intercept of 5, and I go down 2, 3, 4, 5, and over 2. Where's my line? Let me see if I can make this a straight line, actually. Okay, this is best I can do there. And then, let's see. Let's add 3x to both sides for the second equation. You know what? I'll go ahead and change my mind. I'm going to do x and y intercepts. I showed this in class as well. If x equals 0, that means this is gone in the equation. That's gone. So I get negative 15 equals 5y. So divide both sides by 5, and I get y is negative 3. So this means when x is 0, y is negative 3. That's my y-intercept. Now let's find our x-intercept. That means y is 0. When y is 0, then that's gone. So I get negative 15 equals negative 3x. Divide both sides by negative 3, and I get x is 5. So x is 5, y is 0. That's my x-intercept. And now if I draw my line, that's off a little bit, so let's try to do a better job here. Okay, that's still off a little bit, but we'll use it. Now, my intersection point is not a very nice number here. So a couple things that we could do. We could estimate it to the nearest whole point, and that would be, let's see, about 3, negative 1. Or you can try to make it more accurate by using decimals. So I can say something like 2.6, negative 1.5. Something like that. So I would accept either one. This one's, of course, the more accurate one. But again, we're just estimating it. This is one of the disadvantages to graphing, is that we don't know the exact point unless it's a nice point. Okay. So again, the solution for number 8 is going to appear in a few seconds. So the first equation, I graphed it by first dividing 3 on both sides. I got this equation here on the right. I subtracted x on both sides so that I can put it into my slope-intercept form. So I got my y-intercept's negative 3. My slope is negative 1. So you see this red line here is that. Then the second equation, y equals 1/2 x minus 1. Fortunately, I already have that in slope-intercept form. So intercept is negative 1, and then my rise is 1, my run is 2. So 1/2. And you can see that I could make this more accurate. I hand drew my lines, but because I had so many points on both lines, it was okay. So my point right here, where they intersect, that's on both lines, is my solution. I have to estimate it as best I can. So this is what I came up with. If yours is off a little bit, no big deal. It'll still be acceptable. And the last your turn we're going to be taking a look at is number 10. It's a word problem. It's still going to be a system of equations. So we got 2 different video clubs we're going to be looking at. It's going to each represent its own line. So video club A charges $10 for membership and $4 per movie rental. So I could use my movie rentals as my X. So my Y is going to equal that. Right? So that's my cost. So my cost is going to be 4 times number of movie rentals plus a $10 for membership. My second one, Video Club B, Let me label this. That's A. This next one's B. $15 for membership, and then $3 per movie rental. So for how many movie rentals will the cost be the same at both? What is that cost? And we're going to write a system and solve it by graphing. So I'm going to start at $10 for Video Club A. And then it's $4 for every movie rental. So this one's a little hard to figure out because I got one movie rental is going to be $14, 2 is going to be $18, 3 is going to be 22, and then 4 is 26, and 5 is an extra $4 after that, so it's 30. So this is my first like truly nice point on the graph. And then if you wanted to get another point, it's pretty much I'm going up. If it's $4 for every one movie, what I really did was it's $20 for 5 movies, right? Because it's 20 divided by 5 is still 4. So if I add $20 up here, then that's another 5 movie rentals. Okay, so that's my line, my first one. And my second one, I'm starting at $15. And this time it's only $3 per movie rental. I could, let's see, 30 is a nice number, right? How much for 30? That would be 10 movie rentals. So it would be about right here. Because it would be, one movie rental would be $18, and then 21, and then 24, 27, and so on, right? 27 and then 31. Wait, am I doing this right? I'm not. At that point, I did not do that correctly. I apologize. It's supposed to go up $30. It's supposed to be 45. Okay, there we go. And here is my best line that I could draw. So this is a little bit, this is tricky because I can see on the graph that it's going to intersect somewhere around here. Since I did it by hand and I didn't use a ruler, this is kind of a mess. So let's try to figure this out. At 3 movies, I know that my A, so let's do x equals 3. For A, my cost is going to be $22, right? Because $10 plus 4 times 3. And then B is going to be, let's see, 9 plus 15 would be 24. Something like that. Okay. So if it's 4 movie rentals, A is 26, and B is 12 plus 15, that'd be 27. Okay. And if X is 5, that would be 30. Oh, it looks like this is supposed to be my solution now that I'm looking at it. Y is 30 here, and for Video Club B, Y is also 30. Yeah, so there was something wrong that I did when I was graphing it. I wasn't getting the right points at first. So this is what I'm looking at. So I want to erase, well, it won't let me erase it, but I get X is 5, Y is 30 for both. So know what that means, so you want to be able to interpret it. The X means 5 movie rentals, and then the Y is the cost. So cost for both clubs is going to be $30. So this truly is what we want to know here. So if you tried this on your own, or if you took a look at this again, hopefully you will get a nice point right there in the center. I should have actually gone Instead of $3 for every one movie, I could have multiplied by 5. It's $15 for 5 movies extra on top of the the original $15. So I miscalculated there. I went a little bit too far, but this is what happens when you do math, right? Sometimes you you don't take the right approach or the best approach. So there we go. That's it for this lesson. Thank you so much for watching. I hope this all helped you, and have a great day.